In activity one, you discovered a really interesting and I would say beautiful result. If you haven't done activity one, stop this video right now and go back and do it. But what you discovered in activity one was that if you had some sort of function, and I'm just going to draw a function kind of randomly here. But if you have some sort of function and you are interested in finding the area underneath it, so area also known as integral, from like 1 to 4, let's say. So let's see, there's 1 and here's 4. So you're interested in the area from 1 to 4. So you're interested in the area under the curve from 1 to 4. And that looks like this. And if you know some sort of tricky geometry formula, you can figure that out. But what we ended up finding in the activity was that if you look not from 1 to 4, but if you actually go from 1 to x, let's see, let's get the, if you go from 1 to x, what you end up getting here is some sort of new function of x. I'm just going to call it capital F to make it, to distinguish that it's different. And then what we found out just at the end of activity one was saying, oh, hey, look at the derivative of capital F. Just kind of out of the blue, pulling out our old derivative rules from calculus 1. We said the derivative of this new sort of area finding function happens to be the original function that generated the area in the first place, which is kind of interesting. So let's build on that a little bit now. That's really the essence of section 5.3, which is the fundamental theorem of calculus. So let me start off just by looking at an example. Let's get rid of this. Let's look at an example straight from the 5.3 homework. I'll take a look at number 8 here, which just says, use part 1 of the fundamental theorem of calculus, which we haven't even defined yet, to find the derivative of this function. So, let me get on the right layer again. So the function that we're looking at here is another one of these funky area finding functions. So g of x is defined to be the integral of natural log of t from 1 to a sort of unknown finishing point. So natural log of t, if you don't recall, kind of looks like this. Has a vertical asymptote there, and it goes through this point, 1, 0. So there, the function in number 8, the g of x, is actually the integral starting at 1 and finishing over here at some random point x. Here, let's just go and make that a solid line. So they want g of x finds this area right here. So g of x by definition is the area under natural log of t from 1 to x. And there is some function, well, I don't know what it is, but there's some algebraic function that would just tell me this area for any 1 to x. And they are really interested here, not in what that function is, that g of x function, but they're interested particularly in what the derivative of that area finding function is. And we know it's some sort of function of x, right? It depends on this x value here. And we know particularly that it is defined by the curve. So the derivative of this area finding function, I don't know what the area finding function itself is, but its derivative is natural log of x. And there's this deep connection between the process of integrating natural log of t and then taking the derivative of that result, which gets you right back to the original function. So you'll often see them say that the fundamental theorem of calculus, at least part one of it, essentially says that integral and derivative, so the integral and the derivative undo each other, or if you want to put it in math words, that the integral and the derivative are inverses. Okay, so let's take a look at how we could use that a little more directly, and this will get us part two of the fundamental theorem of calculus. Okay, so if we've got some curve, and we're interested in finding the area underneath the curve from, let's say from, and I'm just making this up, from 1 to 8. And we want to know what that area is. So I'm trying to figure out this area right here. We know that whatever this curve, this function is, we know that the area finding function is the opposite of the derivative. In other words, so the area finding function is the opposite of the derivative. Opposite of the derivative being the antiderivative or the integral. And if we want to know the area all the way up to 8, we would find the integral or the antiderivative of f of x. And if we want to go up to 8, we should be able to plug 8 into that antiderivative, that integrated function. But if we don't want this little portion here before 1, don't want that part, so we should be able to take that part off. If we just wanted the area up to 1, that would be the derivative at 1. So the green area that we're actually trying to find would be the anti-differentiated, the integrated function, evaluated at 8 minus, we want to take away the part that we don't want, minus the anti-differentiated function at 1. So we'll take a look at how this works in the next video.